Hello. In this video, I'm going to talk about how we can start to bring in some algebra when we're thinking about arithmetic or linear sequences. So first of all, I'm going to give you two questions and I'll ask you to pause the video, have a little go, and then we'll talk through them. So my first question is this one. Abby has an aunt who's 23 when Abby's born. As they live a long distance apart from each other, her aunt only visits Abby every 5 birthdays. So for example, when Abby's 5th birthday comes around, her aunt comes over, then when she's 10, when she's 15, and so on. We're going to list the ages of Abby's aunt each time she visits. And then once you've done that one, have a go and see if you can list the numbers one less than a multiple of 4. Okay, so to answer the first question, I'm going to begin by listing Abby's ages when the aunt comes to visit. So let's have Abby's ages in the list along the top. So when Abby's 5, she gets a visit, and 10, and 15, and 20, and 25. And you'll notice there that I've just listed the 5 times table, or in other words, the multiples of 5. Now let's have a think about Abby's aunt. Now, because Abby's aunt was 23 when Abby was born, Abby's aunt is 23 years older, so we always have to add 23 to Abby's age in order to find the aunt's age. So if I add 23 to this one, I'm going to get 28. If I add 23 to this one, I'm going to get 33, and then I'm going to get 38, 43, and 48. Now, first of all, you'll notice that the relationship going down works because each time I'm adding 23. But you'll also notice that as we travel through time, 5 years has passed, so Abby's aunt is also going to be 5 years older. So we're also adding 5 as we go along. Now, the ages of Abby's aunt when she comes to visit is forming an arithmetic sequence. It's an arithmetic sequence which has a common difference of 5 because the gaps are 5 every single time. And we would refer to this sequence here as 5n plus 23. And in my head, I like to think of this as the 5 times table shifted up 23 places. Okay. Now I'm going to go through this next one. Numbers one less than a multiple of 4. So first of all, I'm going to list the multiples of 4, which go 4, 8, 12, 16, 20, 24, ... because it would carry on forever if I wanted to. And now I'm going to go for the numbers that are one less than the multiples of 4. So to go down 1 from each of these values in order to get them. So I'm going to get 3, 7, 11, 15, 19, and 23. Oops, sorry. Okay, so these are all the numbers which are 1 less than a multiple of 4. And algebraically, the way I would write this is 4n minus 1. 4 times table, take away 1. I'm going to go through a more full process of how we're going to start thinking about bringing this algebra in now. Okay. Right. So first of all, let's say I described a linear sequence to you as the 6 times table shifted up 2. Pause the video now and see if you can write down the first 5 terms of that sequence. The 6 times table shifted up 2. Okay, so I'm going to go through how to list this sequence. First of all, I'm going to write the 6 times table, and then I'm going to shift each value up 2. So we're going to have 6, 12, 18, 24, and 30. And we could keep going, but I'm going to stop after 5. And I'm now going to shift each of those values up 2 places. So 6 add 2 is 8, 12 add 2 is 14, 18 add 2 is 20, 24 add 2 is 26, and 30 add 2 is 32. You should find, once you've done this, that the times table is the common difference. So it's going up in 6s still, because we've shifted each value from the times table the same amount. Okay. Now, if I wanted to say this in algebra, the 6 times table shifted up 2, I can say is 6n plus 2. And I'm just going to write before that un equals, because that's just technically what we're doing there. Term number n is equal to 6 lots of n plus 2. We can check that this is right, because if I thought about one of the terms, let's say I took the third term, u3, I need to be able to substitute 3 in for n and it come out true. So u3 is equal to 6 times 3 plus 2, and it is. 6 times 3 is my 18, and then plus the 2 gets me to 20. Okay, so the trick here is, think about the common difference. That tells you what times table it is, and then think about how you have to shift the times table to get the sequence. I'm going to do one more example here, and then I'm going to ask you guys to pause the video and see if you can do these ones here. Okay, so looking at this sequence here, 8, 11, 14, 17. This sequence is going upwards in threes. Now, another sequence that I know very well, because I used to chant it when I was in primary school, is the 3 times table. That goes up in threes as well. So this sequence here must be related to the 3 times table. I am going to list the 3 times table above so I can see the shift a little bit more clearly. So I've got 3, 6, 9, 12. If I've gone for the right times table, the gap between this number and this number should always be the same. So I'm just going to check it a few times to make sure it is. So that's a gap of 5. That's a gap of 5. That's a gap of 5. Yeah, this is looking good. That's also a gap of 5. So if I were thinking about describing the sequence in words, I could say it's the 3 times table shifted. Now, to go from the times table to the sequence, I'm going to go upwards. So it shifted up, and I've had to add 5 on. So it shifted up 5. And the way I would say that in algebra is un equals 3n plus 5. That is the formula for the nth term of this sequence. Pause the video now and see if you can have a go at these 5 questions here. They get harder as they go, okay? And if you get stuck or when you finish, play the video again and I will talk through the answers. Okay, so question number 1. This sequence is going up in 7s each time. It has a common difference of 7. So we know that our sequence is related to the 7 times table. If we listed the 7 times table above it, which I'll just do for this one so you can see it, hopefully you can see that it's a gap of 5 every time. So this formula is un equals 7n plus 5. 7 times table shifted up 5. For question number 2, the common difference is 5, so we know it's related to the 5 times table, and this is the 5 times table shifted down 1. So un equals 5n minus 1. Well done if you got those two, that's really good. This one is going up in 1s, so it's related to the 1 times table. This is one that catches people out a lot. I wonder whether it got you. Okay, so it's the 1 times table, but if I list the 1 times table, hopefully you can see that you have to add 8 on. So un here is 1n plus 8, which we can also just write as n add 8. Okay. Next one. This one's going downwards. It's going down by 2 each time. So I'm relating this to the minus 2 times table. And again, this is where when it starts to get tricky, it can be really helpful to list the sequence we're thinking about. I'm going to try and list it here, but apologies if you find it hard to see. So the minus 2 times table goes minus 2, minus 4, minus 6, minus 8, minus 10. And because this is a more complicated one, I'm going to check the shift really carefully. To go from minus 2 all the way up to 7, I've got to go up past 0 and keep going. That's going to be a jump upwards of 9. From minus 4 to 5 is also 9. From minus 6 to positive 3 is 9. From minus 8 to 1 is 9. And from minus 10 to minus 1 is also 9. Okay, so it's the minus 2 times table shifted up 9. So un is minus 2n plus 9. And it's completely fine to leave it like that. But the more experience you get in maths, the less you're going to like a minus sat out the front. So you might be in the habit of changing it to 9 minus 2n. Both of those answers are correct, but a really experienced mathematician would prefer that one because it just looks a little bit neater. Last question. We are going down in 4s. So it's the minus 4 times table. And if you want to, you can list the minus 4 times table, but you will actually find you have to go up 1 from the minus 4 times table. So it's the minus 4 times table shifted up 1, or un equals minus 4n plus 1. And just like before, I'm going to rearrange that to 1 minus 4n, just so it's all nice and neatly put together. Before I finish the video, I just want to mention, as I did earlier on, the idea of checking what you've done, particularly when you get onto ones a little bit more difficult. So for this last one here, I would definitely check it. So I know that I've got 1 minus 4n. Let's take a random number in the sequence. Let's take the 5th one. Okay, I know I should, oh no, that's the 4th one, sorry. Okay, I know that U4 should come out as minus 15. So if I put 4 in here, I'm doing 1 minus 4 times 4, follow bid maths, 1 minus 16. 1 minus 16 is negative 15. So I know that I've got it right. Okay, and you can test more than one if you're really not too sure. Okay, I hope that was helpful. There are going to be some questions for you to do now on finding the formula for the nth term. But the way I always think about it in my head is what times table and then how is it being shifted. Watch out for negatives and watch out because it's possible that the times table you're looking at is something like the 1 times table, or it could be a fraction or a negative times table. So be really careful when choosing your times table.